So, welcome students. Today I have brought you one chapter, important chapter, first chapter of class 10th, real numbers. Before entering in this chapter, I want to take you through some important information related to real number. What do you mean by real number? First of all, I will tell you. Real numbers, every number which you have studied till now. I have used one statement here. Every number which you have studied till now. I am not saying anything else. So what type of series you have studied till now, they all will come in the category of real numbers. So if I start from the beginning, so I have studied about natural numbers, we have done about whole numbers, we have done integers, rational numbers, irrational numbers. So means the whole series will make this real number. So what is different in this chapter? Because if you see, we all know about these series. So what is now? So here we are actually seeing the divisibility of integers. Now the question rises here, like divisibility we know very well. There is nothing new. But on the basis of this divisibility, the mathematicians found three important properties which they have derived, and there was a one mathematician which is Euclid. The name of that mathematician is Euclid, who described a division lemma, and there is a one more application of this particular again lemma, Euclid division algorithm. Now I will take you through one by one. There are three important properties of integers which we will discuss in this chapter. First property which I want to express you in front of you, Euclid's division lemma. If you see, Euclid was a first mathematician who initiated new way of thinking, the study of geometry. So it means Euclid was thinking the mathematics in a different way. He thought like there are some statements which cannot be proved, which is already proved by nature. So they have used one lemma. Lemma, I want to define, it's a proven statement which is used to prove other statements. Here lemma is nothing. Which type of lemma we have used here? They have used the restatement of long division process which we are doing since last so many years. If you just see the Vedic mathematics, we are using this particular lemma. And like for example, 73 divided by 8, we will get quotient as a 9 and the remainder is 1. So it means if I just derive this particular expression in this form, so 73, if you want to verify whether this division is equal or not, so what you will do? First of all, you will multiply this 9 and 8 together. So we will get 72. Then we will add the remainder here. So the same thing we have done and they have written in this form. So this is called the Euclid division lemma. It means they have again used the restatement of division in this form, and they have given this particular restatement as a Euclid division lemma. Nothing else. It's very easy. But there is one important thing. This remainder will be always less than the divisor, because if it is equal or greater than, so it means the further division is possible here. So it means we can say that the remainder is always less than the divisor and it can be equal to 0 or greater than equal to 0. If it is 0, it means it is completely divisible. If it is not equal to 0, it means something is there, but that value should be less than the divisor. So this is the one part which we are trying to explain. Now Euclid division algorithm is one more application of division lemma, but yes, we have used one statement algorithm here. What do you mean by algorithm? Algorithm means there is a series. Actually what we are doing, we are again using this particular expression, but if suppose I have a long division here, I see this 45, if divide 117, we are not getting exact division, means remainder is not 0. So if we do further division like this, like you can see, remainder will be a now divisor for this divisor. So this divisor will now a dividend. So in the same way, now we are getting remainder. The remainder will divide this one. Again we are getting remainder. Remainder will divide the previous divisor, until and unless we are not getting 0. So this is a pattern which we are trying to see. Why we are using this pattern? This is the way to find the HCF. One more way. We all already know that in 6th 7th class we have done we have used a different way. So this is the second way, and I think it's the best way to find the HCF of biggest number also, bigger numbers. Now algorithm means a series of well-defined steps which define a procedure of calculation repeated. Repeated, it means we are using repetition here, until and unless the result is obtained. Where we are using this Euclid division algorithm, it is used to find HCF. So this is the basic difference between this Euclid division lemma and division algorithm. I will explain to you how we will write this Euclid division lemma. Now it's a fundamental theorem of arithmetic. The third property. Third property is very simple. If suppose I say I have written a number 3, or there is a one number I have written 6. So this thing we know very well, but they have written in the form of a statement, because we know but we are not able to define it. But they have defined so many things which we know very well, but we are not able to write it properly. So they have written it like this: every composite number, or suppose I am saying every number can be expressed as a prime, or it will be a product of prime. Suppose I am saying 3, so there is no factor of 3, it means we will say that 3 is a prime number. If there is a 6, it means we can factorize it 3 into 2. So my meaning to explain this particular theorem is every composite numbers can be expressed or factorized as a product of primes, and their factorization is unique except for the order in which a prime factor occurs. So now I have taken one example. I think you know very well how to do the factors. We are doing the same thing here, and we have written in this form. Again, this fundamental theorem is also used to find LCM generally, and we can find the HCF also by this theorem. Now I am coming to the next point. What is this one? Euclid division lemma. Euclid division lemma is like, suppose I want to express in the general form. How you will express it? Suppose I am saying let a and b be two positive integers. Let a and b be two positive integers. So if there is a r and q, if I am putting there are some integers, there are some integers r and q in such a way. Why I am using in such a way? Because we want the relation of these r and q in the same way which I am writing here. A is equal to bq plus r, where r is less than b or greater than or equal to 0. So the meaning of this statement is this. Here a and b is what? If I express it, b is divisor, q is quotient, and r is remainder, and a is dividend. So this is how we can express Euclid division lemma, by using the restatement of again the long division which we were doing in last so many years. Now we are expressing in the general form here, so that it can be used for every type of division, every type of algebraic form also. If we are proving some algebraic part with the help of this particular theorem, then we without number we can prove by using this particular relation. So this is all about this particular theorems which we will use in real number. So first of all, before starting this chapter, you should understand these properties very well. We cannot skip this particular topic, right? So I hope I have cleared you both all the three properties. So kindly please note some important information related to each property so that your conceptual understanding and you can apply the all three properties clearly. Thank you so much.